And here we are again for another geometry lesson in Chapter 9, Section 3. We're talking about right triangles and trigonometry. Good time. So if you have a right triangle, one cool characteristic is if you take the altitude from the right angle, so going down to the hypotenuse. Okay, so that means since it's the altitude, this is a right angle. This formed two new triangles. So there's a triangle here. Oh, yeah, kinda. And there's a triangle here. Let's just highlight it. There we go. Schmoop. And here. So there's two new triangles. Those triangles are similar to each other. Okay, so here is another right angle, right? This triangle is similar to this triangle. And these two triangles are similar to the original triangle. Very cool. So that's the theorem 9.6, the right triangle similarity theorem. So you take the altitude, we have two new triangles, those are similar to each other and to the original triangle, which means we can set up ratios. This side to that side is like this side to that side. Yeah, so here we have a roof. Has a cross-section that is a right triangle. The diagram shows the approximate dimensions of this cross-section. Find the height h of the roof. Now we know that it's a right triangle, and so the altitude here goes to the hypotenuse. Therefore we have two triangles that are proportional, and this small triangle is also proportional to the large one. We know the hypotenuse of the small one. We want to know the longer leg of the small one. We know the hypotenuse of the large triangle and the longer leg. So I'm going to do hypotenuse 6.3 of the large one to the longer leg. Okay, so we're doing hypotenuse to leg. So on the other side, I'm going to do the same thing. I'm going to put the hypotenuse 3.1 to the longer leg, and that would be the height. Now I can cross multiply to solve this, and then I get 6.3h is equal to 3.1 times 5.5. Then we divide each side by 6.3. We do typety-type in our magical calculation device, and we get a height of approximately 2.7. Alright, meters. Okay. Next concept, the geometric mean. Okay, we just looked at a couple of ratios, and setting up this ratio, if we're dividing by the same thing here, and then I have that same number on top there, okay, that is the mean. Okay, that's the mean, and these other two are called the extremes. Now, I could also set it up to look like this. Okay, a divided by x and x divided by b. Okay, the geometric mean is the positive square root of the product of two numbers. Okay, if you want to see how that comes about, here's the ratio we just had. Okay, in order to solve this ratio, we're going to cross multiply. So I'll bring the b over there and the x over here. Right, so I get AB on this side and x times x here. Well, x times x is x squared. If I want to solve for x, I have to square root that. Okay, so square root each side, and then I get this resulting equation down here. That's the positive square root of the product of two numbers. Alright, so the geometric mean is set up from this proportion, so x squared is ab, or solved x is the square root of ab. So for example, if you have a is 9 and b is 4, then the geometric mean is 6, because 9 times 4, 36, square root of that is 6. Alright, finding the geometric mean. Okay, the geometric mean, x is equal to the square root of the product of these 24 times 48. That's a 4 there. Alright, and 24 times 48, the square root, we do typety-type-type, or we can simplify this actually. Let's see, 24 times 48 is 24 times 2. Okay, now we have a perfect square right here, so we can take this out, and then we have 24 times radical 2. So the geometric mean of those two numbers is 24 radical 2. Okay, now if I have this triangle that we were looking at earlier, and I'm considering this altitude here, okay, and this, or let's call it the height, is both the longer leg of this small triangle and it's the shorter leg of this large triangle. So if I was to call this side, let's say this is A and this is B, then I can do longer leg to shorter leg. Okay, longer leg is A to shorter leg H, and longer leg over here is H to shorter leg B. Right? Notice I've got H here and H there. So I can cross multiply this, and then I have H squared is equal to AB, and boom, geometric mean right there. Yeah, I can solve. Okay, this is 9.7, the geometric mean or altitude theorem, where CD, this altitude, is the square of the product of these two segments. In words, if you would like that, here we have all those fun words to explain that. The geometric mean leg theorem is similar, but now we're using the legs. So we have CB, the hypotenuse, okay, and DB and AB. All right. So I'm using the hypotenuse to this leg, hypotenuse of the large triangle to its shorter leg is like the hypotenuse, the shorter leg of the large triangle. This right here is also the hypotenuse of the small triangle. So hypotenuse to short, hypotenuse to short. And that gives us these formulas right here and in words. Right there, if you like to add that to your notes, you needn't, because that's a lot of words, but if you want to read through it, you are welcome to. All right, here, what do we know? We know 6, this segment right there. Notice that the 6 is in the middle of this segment. That's how you know that 6 only applies to this. 3 is this part right there. Okay, and then 6, longer, I'm going to just make a note, long, short, okay? Longer on top, shorter on bottom, so that's 6 to x, and then is equal to, longer here is x to 3. Cross multiply, we get 6 times 3 is equal to x squared. Therefore, x is the square root of 6 times 3. Now, 6 is also 2 times 3. So 2 times 3 times 3, and there's a perfect square. So x is 3 radical 2. All right, in problem B, we're using hypotenuse and leg. So hypotenuse and leg to set this up. Let's go with the big triangle first. Okay, the hypotenuse for that big triangle is 5 plus 2. And the leg is y. And then in the small triangle, the hypotenuse is y. And the leg is 2. Cross multiply. 5 plus 2 is 7 times 2 is equal to y squared. Square root it, and y is equal to the square root of 14. And that's how easy that is. Alright, using indirect measurement to find the cost of installing a rock wall in your school gymnasium, you need to find the height of the gym wall. Use a cardboard square to line up the top and bottom of the gym wall. Your friend measures the vertical distance from the ground to your eye and the horizontal distance from you to the gym. Approximate the height of the gym wall. Let's look at the illustration over here because they've done a pretty good job, because from the text it's kind of hard to imagine what's happening. So here we have that square, right? That's a cardboard square, therefore we know this is a right triangle. Cardboard square, we know this part, we know the height, we want to find this part. Well, we can set up our ratios because we know that these are similar triangles. So here we have the longer leg and shorter leg situation, right? I'm going to put longer leg on top. That'll be W for this one to 8.5 and is equal to longer leg here, 8.5 over 5. All right, and then we could cross multiply, but I know the 5 will come back anyway, so I'm going to multiply this over here. So that gives me W is equal to 8.5 times 8.5 divided by 5. And that is 14.45. Now, the other way you could have set this up is using the geometric mean altitude theorem. Okay, by that we know that the altitude, right, the altitude squared is the two segments, the longer leg of the larger, W times 5, and the altitude in this point was, this case was 8.5 squared is W times 5. So that's another way you could have set this problem up using the geometric mean altitude theorem. And then solve, you get the same results. Boom, there you have it. Good times in geometry. Check back again next time for another fun lesson.